Thank you for that very nice introduction. So in this talk, I want to introduce you to Mint. It's a new HTTP client created by myself and Andrea Leopardi, who is another Elixir core team member. So in this talk, we're gonna look at the design of the library, some of what it takes to build an HTTP library in Elixir, and some of the future plans that we have for Mint and surrounding Mint. So why do we decide to create a new library? So I'm the maintainer. I am one of the maintainers of the Hex package manager, and the HTTP client that we use for the Hex mix client has always been HTTPC, which is the built-in client with Erlang OTP. And we always had some issues with this client. One issue is that it doesn't give as much love as it maybe should get. And for the Hex client, we always need to support back to OTP 17 and Elixir 1.0. So even when bugs are fixed, we still need to do workarounds to support these older versions. The other reason was that for a while there was discussions to remove HTTPC from the standard OTP distribution. And if that was the case, we needed to add an HTTP client to Elixir core itself, because we need to download things like the rebar build tool and for example Hex. In the end, it looks like HTTPC will remain in the OTP distribution, so we will probably not. It's not likely that we will be adding Mint to Elixir core. But the other reason was that we also wanted to explore a new idea for a kind of new design for an HTTP client that is not based on processes and instead based on pure data structures, and we will talk about that more later. But before we start looking at the library in more detail, let's first see what it looks like to make a request with Mint. So first, what we do is open a new HTTP connection to the server. If this is successful, we get a connection struct back that holds the state for the connection. Secondly, we send a request to the server. The first argument is the connection that we got back earlier. We have the HTTP method get, the path, empty list of headers, and the request body. So thirdly, we want to start receiving responses with the stream function, or we want to start receiving the response. So the stream function again takes the connection as the first argument, and the second argument is a TCP socket message, which is a message that the socket, after we connect to the server, the socket will start sending these messages to our process. So what the stream function does is that it returns the response in parts, which we'll finally be printing with the InSpec so that we get an example of what that can look like. So these four tuples that we see here are what we call response parts. So they are essentially parts of the response. So this where the status, the headers, data is the response body, and finally we get the done response to signal that the response is finished. And along a long response may be split over multiple TCP messages, and we will need to keep. If that's the case, we will need to keep receiving messages until we get the done response. So that was an example on how to use Mint. So let's next look at the library design that we decided to use with Mint. So the main goal was to not use any processes and instead base it on pure data structures, which is the connection struct. So the only side effects that the library has is when we create the socket, when we set up a new connection, and when we send data on the socket. So like we saw on the previous slides, the user that handles receiving TCP data and then passing that to the Mint library. We also wanted everything to be streaming to avoid unnecessary blocking and to keep the library as general as possible. Since we're not using processes in Mint, it's more flexible in the ways that it can be used than most other HTTP client libraries, I would say, because you can choose the process architecture that you want, and you can choose if you want to do connection pooling, you can do that however you like. But designing a library to be side effect free can also make it harder to use for simple use cases. Like the previous slide, we saw that it's a bit involved. It's multiple steps to just make a simple request and get the response back. And if you want to reuse connections, it's up to you, the user of the library, to store the connection struct and maybe handle reconnects and so on. And for those use cases, it might be better to use another library, or maybe a library that wraps Mint with a easier interface. So because of the processless design, the connection state is stored directly inside the user process. Like you can see here, is an example of the HTTP1 connection struct. So this is unlike a library using processes where you would likely instead have a connection struct that you store. You would likely have a process ID or similar that points to a process that holds this state separately. And if the library uses a connection pool, you likely wouldn't have to explicitly open a new connection. Instead, the pool could do this behind the scenes when necessary. So responses are streamed back in parts, like we looked at yesterday in the previous slide. So this gives the user more flexibility, and it's important if you want to wrap Mint and not lose any performance. So for example here, since we're streaming, if we receive the first TCP socket message here as first message with only partial data, then you will only get maybe part of the response body, and you have to call this function again the second time you get a TCP message on your process. And then you have to keep doing this until you finally get the done response part. In Erlang OTP, sockets can run in two modes, either passive or active mode. And in passive mode, it's up to the user to explicitly call a receive function to get data from the socket. This function is blocking, so you can't wait for data on more than one socket at a time. So instead, Mint runs sockets in active mode, which means that the socket will instead send data and socket events as messages to the process that owns the connection. And those messages looks like this for TCP and SSL respectively. And when you get these messages, it's up to you, the user, to pass in this data to Mint. So also to just look at the response parts. So we have the status, headers, data, done. We also have error when a request failed. And for HTTP2, we also have PONG and push promise response parts that we're going to look at later. So what does it take to design a processless library? So it's really not that difficult in the end, because really the hardest part, at least for me, when doing a library like this, is to actually handle the processes, because you need to know about links and monitors, what happens if a request times out, and what should you do then? Should you maybe kill the connection, and so on. if you decouple your pure code from the code that uses parsable, the internal API would be almost identical anyway. And if you've done this decoupling, at least I feel like it's easier to test the code, because I think it's easier to test side effect-free code than code with side effects. And in the end, you can always add processes later, and that's easier than maybe changing the process architecture of the library. So we talked about what can be easier, but what can be harder when we don't have processes. So one thing is that we don't have side effects, which can be harder for the user of the library. So one common issue that we already started to see is users forgetting to reassign or store the connection struct between calls to the library. And if you're using processes, you of course don't have this problem, because the separate process is storing this state for you. And unfortunately, we cannot really detect this mistake. And the error messages can be really confusing, because the state is essentially corrupted if you don't store it between calls. And if you used plug before, you may have run into this same issue. So one of the other difficult problems as the implementers of the libraries was to do HTTP proxying. So to explain it, let's first look at different ways of doing HTTP proxying. So the first way is that you can do proxying per request. You connect to the proxy server, and for each request to the proxy server, you give the full URL to the end server that you want to send a request to. The problem with this is that, for example, we use HTTPS here, but we don't have end-to-end encryption to the server, and the proxy would be able to read all the data. So the other way to do proxying is what's called tunneling. So the same way we connect to the proxy server, and then we set up a tunnel with the connect request, and then inside this tunnel we can create a TLS session directly against the end server. And when this session is set up, we can send a request just like if we were connected to the end server directly. So the first way is sort of becoming deprecated, and the tunneling is the way to go for the future. But unfortunately, we need to, as a library, we need to support both, to support legacy proxy servers and so on. So we have this mismatch where we sometimes need to proxy per request, and we sometimes need to proxy per connection. And it becomes more complicated with HTTP2, because with HTTP2 you don't start a tunnel per connection, you start a tunnel per stream. So you can have a single connection to a proxy server, and then start and then have tunnels to multiple different end servers. So we have kind of this mismatch between the different versions and the different ways of doing proxying. And the goal for Mint was never to limit the HTTP protocol. For example, Mint doesn't support WebSockets, but the API allows you to implement WebSockets on top of Mint. So having this problem with proxying, finding a good API for it, that was very difficult for us. So unfortunately, we failed to find a good API for it that is both straightforward and the most efficient. And the why I'm talking about this proxying is that I wanted to show one of the cases where the low-level API that we have in Mint kind of failed for us. So for example, if connections were abstracted away for you, you could kind of hide if you're doing proxying per connection, per stream, or per request. So we have this API now, which works, but is not the most efficient in all cases. And if you if you are building a library on top of Mint, or if you really need high performance proxying, we recommend that you implement a custom solution for yourself. So what are the use cases for Mint then? So one use case is when you have another system or another library that provides the process architecture for you. One such library is GenStage. Because with GenStage, it creates the processes for you, and there's little reason in some cases to put the connections in separate processes if you already get the concurrency from and back pressure and so on with the GenStage. And I feel like you will have less complexity when you use less processes. Another reason for using Mint is when you need really high performance. So Andrea Leopardi, who worked with me on Mint, worked on a high performance push notification system a few years back, and he tried different HTTP clients, but none really gave the flexibility and the performance to use with GenStage. So in the end, since this was a few years back, he ended up having to build a custom client that was really for their specific use case. So we use those lessons when we design when we built Mint, so that you hopefully wouldn't have to build a custom client anymore. So there's a really good blog post about that project that I linked here. Another example is Pete, who is here somewhere, Pete Gemachi, is building a pooling library around Mint that is called Mojito. And he's been doing a few benchmarks, or not a few benchmarks, a lot of benchmarks with Mojito and other HTTP libraries. And so I recommend you to check that out if you want to compare different libraries. And even though Mojito isn't real at the top, the results are very promising, I would say, because we haven't really done a lot of optimizations on Mint and Mojito yet. So I would say that the good results are mostly due to the design of Mint and the pool itself. And we always wanted Mint to be flexible enough for any use case, really. It might be more work to use in some cases, or you might need to use a library that wraps Mint. So we looked at the library design. So next, I want to talk about a little bit about how we handle the HTTP protocol in Mint. So we support both HTTP 1 and HTTP 2. The difference is that HTTP 2 API is sort of a superset of the HTTP 1 API that supports concurrent requests and a few other features. So if you want to use HTTP 1 only, you use the HTTP 1 module. HTTP 2 only, there's a module for that. And if you use only the HTTP module, then we will do version negotiation. So we will connect to the server when using HTTPS. We will connect to the server, and we will say that we want to use HTTP 1 and HTTP 2, and the server responds back with the version that it supports. So as I said earlier, HTTP 2 with HTTP 2 you can do concurrent requests, which is also called multiplexing. You can cancel requests. We also support back pressure with window sizes, and we have ping and pong frames that can be useful to measure latency or check if the connection is alive. We don't support prioritization of requests or streams. And another thing we don't support is upgrades HTTP 1 to HTTP 2 when you don't use HTTPS. But I think it's on the roadmap to support both of those. And one popular feature of HTTP2 is server push, also known as push promises, which you can see here. The push promise is one of the response parts that we have. And a push promise is really a request that is started by the server. So if you receive a push promise, unless you cancel that request, you need to make sure that you handle the headers, the data, response parts, and so on, just like you would for a normal request. So I also want to talk about how we do HTTPS. Many HTTP clients in the ecosystem, they all support HTTPS, but they are not what I would call safe by default, because most of them don't do any certificate verifications and so on. The only client that I know of that does that is Hackney. We also want to reduce any surprises. Security should be opt-out, not opt-in. And we also provide a certificate store, which I'm going to talk a bit about later. So to show you what we mean by safe by default, if you use the built-in HTTP client and you make a request to a test server on bad SSL that provides a self-signed certificate, that will just work, which it obviously shouldn't, because we want to use a certificate that is signed by a trusted certificate authority. And instead, if you use Mint, you will get the SSL error like you should. So we also want to reduce surprises. So if we use Hackney to make a request to the same server, we get the error just like we should. But say that we want to tweak some of the settings. For example, we want to use a specific SSL version, or say that we want to use a specific cipher. Then Hackney will suddenly start accepting those responses. And the reason for that is that Hackney doesn't deep merge the options. So this is what I would call very surprising. So if you want to tweak some of the options, you actually need to reproduce all the different settings that all the different default settings that that Hackney has to be able to still do safe HTTPS. But with Mint, we document all of those options that we support, and we do deep merge of the settings, so you wouldn't have this issue with Mint. Another problem with doing SSL on Erlang is that Erlang has very good SSL support, but one thing it doesn't support is getting the certificate store with trusted certificates from the system that you are, the operating system that you are using. So instead, to work around this problem, we provide a up-to-date certificate store, which you can just add as a dependency. And when you've added this dependency, we will pick that up automatically, and we will use the certificates from the dependency. And I want to thank Bram for all the work he's been doing on HTTPS in Mint and in the Hex client and so on. He had a really good talk at ElixirConf Europe a few months back. So I suggest that you, if you want to learn more about SSL, not just about HTTP clients, I suggest that you go to his blog post and check out the video and the slides from his talk. So we started looking into what HTTP 3, not in that much detail yet. But we started looking into what would be needed to do HTTP 3 in Mint. So one thing we need is the latest TLS version. OTP 22 was just released with some initial support for this, and I think we will get more support for it in future releases. But we might also need some changes to the SSL module, because with HTTP 3 we need to first on we're running on the UDP instead of TCP. HTTP 3 handles the crypto setup itself. So I think we will need some changes to the SSL module to be able to support this kind of custom way of doing TLS sessions. The other problem with HTTP 3 is that we don't have automatic version negotiation because it runs on a different underlying protocol. So with the API, with the low-level API that Mint has, unfortunately we cannot do automatic version negotiation for HTTP 3. So you would have to kind of detect that yourself, and then yourself decide what version that you want to use. So what's in the future for Mint? Really not that much. We want to have a stable API. Hopefully we have already found that, unless we find any major issues. We'll also be discussing supporting or providing a more higher level API, probably combined with some connection pooling. But in the end, we decided to not make that part of Mint, and instead we want the community to build these libraries around Mint. We have Mojito that I talked about earlier, and we have another library called After 8 that Andrea has started building. So in Mint itself, not that much, but hopefully we will get more libraries surrounding it in the future. So that's it. Thank you for listening. I'm not sure if we have time for questions or not. We have a couple minutes, so any questions? Dave, yeah?
Have you given any thought to integrating what you're calling streams with the Elixir stream module? I know it's kind of backwards.
Yeah, so Dave was asking if we have looked into integrating the streaming in Mint with the streams that we have in the standard library, correct? So we haven't really looked into it, but I think it would have the same problems that you were talking about in your talk, that it's hard to make it fit when it's push-based, because you can build a stream around it, but you get into problems with what if you want to cancel the stream or only want to take a few messages out of the stream, because then you're gonna leak TCP socket messages and so on. So unless the stream wraps the whole connection, which is not efficient for HTTP 2, for example, then I don't think it would be a good idea, unfortunately. Unless you actually put it in a separate process, but then you kind of lose a bit of the values or the benefits that you get from Mint. So I can't see anyone, but yell if you're raising your hand. Okay, yeah, thank you.